Okay, we should be on. Okay, so now we're live. Hi, everybody. My name is Maria. Welcome to our dxTechTalk Frontend Day. Before we start, because it's just 4 p.m. now, so let's wait for some people to join before we start. Please write in the chat here where we're from, just so I can take a look and see where everyone is today. Hot weather today in Central Europe. Oh, you're right. I'm from Portugal and I'm here right now and it's hot, but it's getting even warmer in the next days, but I'm excited for that. It's the weekend soon, so we get to go to the beach. Okay. So we have a lot of people here already, which is nice. Hi, everybody. Kosovo, oh, nice. Tbilisi, well, Portugal, Nepal. Okay, that's nice. We have people from a lot of different places here, which is interesting. A lot of variety. Moldova. Welcome, everybody. Serbia. Okay, that's interesting. Albania. We have a lot of people from Portugal, which is nice. Yeah. It's normal also because we have an office here, so it makes sense. Okay, I'm very surprised because we have people from like so many different places, which is well, usual. We usually have a lot of people from different places, but today there's so much variety, so I'm impressed. Cool, Romania. Okay, that's nice. It's nice to know where everyone is from. Thank you. We're still, some people are still gonna join, but I'm going to start talking, and then as they join, they can just catch up. So, welcome to dxTech Talks, a series of free tech meetups organized by DevExperts. If you don't know DevExperts, we're an international fintech company, and we specialize in the development of financial software solution and services for the global capital market industry. We were founded in 2002, and we have R&D centers in so many different places like Jersey City, Porto, where I'm from, Vilnius, Munich, Dublin, Tbilisi, Sofia, and Istanbul. We started this project to be more in touch with the tech community and share our expertise in fintech and other industries, and discuss our projects, our technologies, our tools. Besides, online, we have these events online, but we also organize them in person in Sofia, Porto, and Tbilisi. So if you're in any of these locations, you're more than welcome to join an in-person events. Also, if you want to stay up to date with our events, you can follow us on our social media. We're on Facebook, LinkedIn, Instagram. We're on meetup.com, on Eventbrite. So you can just follow any of these and you will find our events, and you can stay in touch and learn about our upcoming events. We announce all of them in our corporate profiles, so if you follow them, you'll find them. Today, we have two programs. Today's program is two tech talks. They are around 25 minutes each, and at the end, there's a Q&A session. So if you have any doubts, feel free to leave them in the chat, and I will read them to our speakers. If it happens that we don't have enough time for everyone's questions, because that sometimes can happen, you can also message them on LinkedIn. They will put their LinkedIns at the end of the presentation, so you can just reach out to them. I'm sure they would be happy to answer them. So, our first speaker today is Vladimir Glukhov. Vladimir has been working as a front-end developer for over 5 years, mostly in fintech-related projects. He has a very interesting hobby, which is robotics and programming. So in his free time, he enjoys learning new technologies and trying to use them. And today, Vladimir is going to tell us all about his hobby and what he's built with it, which is pretty impressive. I've seen it in person. It's very cool. You'll see it today. So, Vladimir, welcome.
Now, hello.
Hi.
So, Let me start sharing screen.
Okay, thank you.
Okay, I hope you see this now.
So we can see.
Okay, good. So, hello everyone, and thank you for joining. And today I'm going to tell you about this hand gesture recognition system and how we can control a robot uh, via the internet. And uh, as it was said before, I'm front-end developer. A few words about me again. I'm in the experts. I have been working since 2022, and my hobby is programming, robotics, and just new technologies. And so let's say a few words about this robot. This robot is uh, my hobby. I just made it some time ago, and it has a few sensors, it has a camera, it can do a few commands, and at least the most important part here for us is that this robot can be controlled via the internet. And let's take a look under the hood of the system. This system includes three main components: a robot side, the web server, and the user. On the robot side can be some small PCs like Raspberry Pi. There is a Node.js server that connected via socket connection to the internet. Um, in the web, there is a web server. It is developed somewhere. It also uses Node.js like Express application, and of the most important part here for us, it is a user side. For the user side, there should be just the user and the modern web browser like Chrome, Safari, Opera, Mozilla, and that's all. Then user just need to be connected to the internet, reach our web application, and run this like a usual website. Okay, now let's be focused more on the web part of this system because we are front-end developers. So let's imagine that we are going to develop this system from scratch. What we are going to do? At first, we should put our goals. For example, can be like this application should represent the data and state from the robot. Also, we should send commands from this web application to this robot. We can use some libraries for it, and at least this application should be modern, interesting, just because. Okay, now let's think what we can use here. We can use React for front-end part. Also, we are going to use TypeScript for socket connection. We can use socket.io libraries. We can use something also like SAS, interpreter, but stop. Isn't it boring? Jackie also thinks so. Okay, let's add a little bit more features here. Let's use WebAI here. For this, we can use TensorFlow.js library, for example, and we can use a few existing models from MediaPipe libraries. Okay, now Jackie is happy. Thank you, Jackie. And let's continue. But before we start, deeper, moving deeper, I'm going to tell you exactly what is AI. WebAI. WebAI is the idea of bringing AI capabilities like face recognition, image classification, object detection, and so on, and run these features directly into the web browser. And for this reason, we don't need to set up some hardwares. We don't need to set up special application. We just need to run the web browser, reach the website, and it's all. It's really simple. Now, let's think what is the hand gesture recognition system, and I'm going to tell you about the system a little bit more. I'm going to tell you about the architecture of the system, how to add AI capabilities into the system, how to use existing models, and also how to train, create, and use our own model for hand recognitions. Okay, let's see what the architecture of the system. You can see the diagram here. For example, we can use a web camera from our laptop, or we can use a USB camera to connect to our PC or laptop. Then we're going to use a hand recognition model, existing model. It is important, and I will say why later. Then we will use our custom model for gesture recognition, and then we will send commands based on current gesture to the robot via the socket connection. These small details here. Okay, but what exactly AI models? You can think a model, it is just a program. We can create a model using some tools like TensorFlow.js, but then we need also to collect a lot of data for this model. Then we need to label this data, train our model, and after this, we are able to use this. In this case, um, we don't want to create a hand recognition model, not just recognition, hand recognition model, because it requires a lot of photos of uh, people with hands to label these photos, and actually there are a few pretty good models for hand recognition, and we can use some of this model for the web browser. And let's see how to use it now. Okay, just to add AI capability, we just need to add some libraries to our web application. At first, we just need to add TensorFlow/TFJS library to work with images, with some tensors for AI. And then, as we are going to use hand recognitions, we can add this library. It is a pretty fast library for a web browser that can recognize hands on the image or on the video element. But it's enough? Of course not. We also should know how to use these models. What I'm going to say again about this model. Each model has a different input format and has a different output format. What does it mean? For example, each model has, as I said before, has a different input format. It could be image size, it could be some arrays, type of arrays, or something else. For current model, we just need to go to this documentation for this model and investigate this documentation. It is important part here because usually some developers forgot about using documentation, and it is really important because there are not so capability here. Okay, now let's see what is our hand landmark detection model that we installed before. As you can see here, as the input format for this model, it is just an image or video ref element. It's not so interesting here. The most interesting part here is an output format. You can see the format here. It is just an array with some objects, usually two objects, like left hand and right hand. Each hand has key points up to 21 elements here. You can see the scheme of each key points, what the position of our hand for each key. Now let's see what is actually the scheme points. The scheme points are responsible for 2D representation of the screen, but for us more interesting, key points 3D, they are responsible for 3D orientation in the space. And based on these key points, we can create some recognition systems for gestures. Okay, now let's see how we can use this model in our web application. For example, we are using React application, and there are, based on the documentation for this model, we just need to create some detector. Then we can use this detector, calling special method here from them, and provide some images or video elements and get some arrays of hands. Okay, let's see how we can use it. There is an example of the code of React code. At least this component should have a video element. You can see this element here. It has two refs, a video ref and detector ref. Let me tell you what does it mean. Okay, at first we need to initialize a web camera. How to do it? It is just a browser API. We just need to call navigator.mediadevices.getUserMedia, and it will return a promise with video stream. Then we set the stream as SRC object for this video element. Then we need to initialize our hand detector. It is also nothing special here. We can do it as another use effect and save this detector into the ref. And at least the last here, we need to combine this video element and this detector. Okay, we have this video element and this detector. Then let's create some function that call this method from this detector, this special method from the detector API that as argument we should provide video element or image element. Now in our case it is video element ref video element. Then we can use the request animation frame to make it on time, and it's so on. Here we can get hands and work with this data somehow. Okay, now it's time to create our own model. As I said before, a model is just a program, and you can see here the current working model for hand recognition, hand gesture recognition, sorry. I reached this model based off some experiments and researching the web. Don't want to say some words about AI and this architecture, but for us, what is important here is an input shape. It means that you can see here that it is input shape is array, roughly say is array of 21 elements with 3 elements. It is nothing special like key points, 3D key points from this hand, from previous hand recognition model. And each number is just this position. And then of output layer, it is just out an array with, for example, 6 elements. That means that this model will give us 6 gestures. And it's all that what I can say here. Now let's see what should be our next step. As I said before, we just next step after creation model should be collection data for this model. And as I said before, we just need to collect data. For this, we need to imagine all types of gestures that different enough, and we need to collect each key points for each gesture using our web applications. There should be some interface for it, and for each gesture we collect these key points, then we combine them into array, create labels for it, and train this model. It is a simple state, but there won't be a code because it is another part of it. Now, let's see how, for example, how we call the train method. For example, we have labels ref where we collect the labels for our data. Then we have data ref where where we collect the data key points for each gestures. They are just combined together. Then we need to convert this simple arrays into tensors. We can use TensorFlow library API to do it. Then we need to provide these tensors into feed method from this model, wait for some time, and then we can save this model into memory. We can save this into the local storage or into the just download these files for this model and use it somewhere else. Okay, I hope it understandable a bit. Now let's see how it can work. You can see here a small example before sending some data to the robot. Now, when we have our model, we should combine this model and set data from previous model to our custom gesture recognition model. You can see how it's done here. From previous model, we got some points to the example of the code. Then we pass this point into this model, also called the .predict method with these tensor points. Then we execute some arrays from it. You can see the data here of this array. It is the array of predictions of current gestures. For example, on this image, we see that number one has the bigger value from this array, and it means that this number is a predicted gesture, and it is runs from time in just a few times per second. You can see how it works here. It's pretty fast, and based on this gesture, we just set some commands to the robot using WebSocket connection, and it's all. And I will skip this part because it's not so interesting to connect by sockets. And let's see a short demo here. You can see how it works. It is a video from my home. And there are some examples. For example, there is two robots together that also connected by the internet, and it runs directly into the web browser. I can work with my phone, tablet, PC, or laptop. It doesn't matter here. And it seems that it's done, and it's time for conclusion. So what I can say that Web AI, it's not so difficult. It has very huge community into the internet, and there are also a lot of libraries for object detection, image classification. There are also some LLM models that you can run into the web browser. It takes just 4 gigabytes of your RAM memory, but it's possible. And also, I'd like to say that WebAI with tools like TensorFlow JS, that we can run everything in the web browser. It is pretty fast and private. We don't need to set data to the web server to wait for requests and so on. And this project shows how we can combine web development, AI, and IoT together and create some additional interfaces, some additional applications that just make our life better and more interesting. And thank you all for listening. There are links for my blog and for my LinkedIn page. You can make screenshots. Just wait a few seconds here. Okay, and there are links for my company. You can follow it also in Instagram, LinkedIn, and other social networks. And um, seems it's time for questions to me, and I wait for it.
Thank you, Vladimir. That was great. Very interesting. I've seen this presentation before at our office in Sofia, and I was lucky enough to see the robot in person, and it's pretty cool. Congratulations for doing that. It's
Yeah, thank you.
You know, you always see like these robots on, TV and everything, but actually seeing someone building something like this and explaining how to makes more sense. I still would not be able to do it myself, but it's amazing to see that other people can
Amazing,
do.
Sam. Yeah,
So we do have some questions here that I will answer. Sorry, I will say to you.
you can
There's
say.
just one that I can answer myself is will the meeting be recorded? I missed the beginning. Yes, we will leave the live on YouTube. So if you missed something or if you want to rewatch, you can do it. It's perfectly fine. So now for questions. The first one that we have is how much time did this custom model take for training?
Okay, thank you for this question. So I ran this a few times. It just took maybe 2-3 minutes for each training, so directly into the web browser. Yeah, and also maybe it is more interesting that I was using a Mac M1 machine. It's pretty fast, and maybe in another device it will take more, maybe 5 minutes, but it's not so much data here like for image classification. It's just pretty simple arrays with lengths, not so much data.
Okay, cool. Thank you. So now we have another question is the TensorFlow GS has its own pre-trained models, but you can train your own. How does the process look?
Okay, so I described it somehow, but what I should know here is that before training, we need to collect this data. We can collect this data using just web application, using maybe another application. Then we just need to pass this data into TensorFlow. It is just arrays of numbers, and there are a few of them. Then we should use existing model. Our existing model doesn't require training. Um, for example, we have our custom model. Then we need to pass this data uh, to this model. But before this, we need to convert this simple arrays into tensors. It is also not so difficult, but sometimes it requires time to find this format, like 2D, 3D for tensors. It depends on the model that we are going to train.
Okay, nice. I hope that
I hope I described this
I think you did. I think.
somehow. Yeah.
Don't worry. We had another question. Where can I record those gestures?
Sorry, which gestures record?
S- Sorry. Yeah, I think like the gestures that you were doing and the videos.
Yeah, it was gestures just from my imagination, imaginary, im- sorry, imagination, and So it's just was collected by predictions from hand recognition model, existing model, and then I just collected this key points, for example, 30 times per second, like to add this in one arrays of data. And for each gesture, it took maybe a few seconds, maybe 10 seconds for each gesture, then just click to another button and so on, step by step to collect key points for each gesture.
Okay, interesting. So for the last question, where is there like any place to learn about this stuff, like maybe online or something?
Yeah. I really can recommend uh, a course on YouTube. It's called also like the same TensorFlow.js. Uh, it's free course. It is from Google, from one guy, Jason Myers. Uh, I took this course maybe a few years ago, and it really helped me to go into this topic to Web AI. And yeah, all of this based on this course. It's this course not so difficult. There are a few examples and so on, and yeah, it's pretty nice to have this.
That's nice to know. Okay, thank you. Maybe I will take a look at that course one day and see
If
if
you
I
want
can
to
embed.
go to Web AI, can yeah. Okay, so thank you all for attention, and I'm still here.
Thank you so much, Vladimir. That was great, and I hope that you guys liked it. Thank you so much for your questions. So now, without further ado, we will move on to the second presentation, which is by Ekaterina Felk. Ekaterina has been working in front-end for 10 years now. She specializes in React and has built numerous apps across fintech, oil, banking, and so on. And she's always learning from each project. In all her time working in front-end, which is a lot, a decade, she's had to make a lot of decisions, some good, some bad. And today she's ready to tell us how all about it. So, Ekaterina, welcome, and you can take the stage.
Yeah, thank you, and hello, everyone. Thanks for coming and watching our dxTechTalk session. Today, we are going to explore how to make smarter and more confident decisions in front-end development. And I am senior front-end developer, and I've been making front-end decisions for 10 years, including 4.5 years at DevExperts. And before coding, I was a physicist, and that scientific mindset still drives me to dig deeply into every question. And recently, I realized the decision-making process is quite challenging for me, and that's why I started investigating this topic. And making decisions is not just challenging, it's a crucial part for both our lives and software development. Why? Let's break it down. We make decisions constantly, from naming variables to picking an architecture, and every line of code is our choice. Also, bad decisions can compound over time. Small assumptions can snowball into tech debt and extra rework. Also, time and resources are limited. We can't explore every possible option. Uncertainty is a norm. We often don't have all the information, and it impacts the whole team. Our decisions affect not just us, but our colleagues and the final product as well. And now please think about the time when you struggled with some decision at work. Was it really, was it easy or a real headache? Which obstacles have you faced? And maybe it was responsibility. We all feel the weight of knowledge on our shoulders while making the right call. Also, it could be limited time. Deadlines don't wait for us. Fear of failure. Nobody wants to be that one who breaks the production. Analysis paralysis. You go round and round and the clock is keep ticking. Maybe it can be too many options. You want perfect clarity, but it's often impossible. And of course, cognitive biases. And who wouldn't like to have a crystal ball to see the future? Unfortunately, we don't have one, so we need to develop our decision-making skills. This book was kind of inspiration for me. It's not about programming, but it offers tools and frameworks for decision-making. And today I'm going to share how we can apply some of these strategies in our work. And let's start with interactive scenario. Just imagine that you discovered bug in production and no one has reported it yet, but if so, it would be critical issue. After digging a bit, you trace the issue in a large old legacy code, and the original developer left the company 2 years ago, and no one in your team really understands it. And also, it's Friday evening. Spicy enough, isn't it? And pretty relatable. So let's take a moment to calm down and assess the situation. What can we do? So we can try to fix it immediately or start refactoring, or we can just go home with the hope that on Monday the issue will disappear itself. And seems the last one is not our case because we are responsible developers. So let's cross it out. And now we've got 2 real options and we want to figure out the best approach. So let's build a node.gold pros and cons table. So what do we have? We can, fixing the bug could be a fast solution with minimal changes, but it doesn't improve the code quality. Maybe we should refactor instead. It sounds like a long-term clean solution, but what if it will be so time-consuming that clients start noticing the broken feature? Maybe a quick fix isn't so bad, but what if I get stuck debugging for days or can't fix it at all? Okay, let's refactor then. It looks like a safe option. However, what if I introduce even more bugs during refactoring? Fix or refactor, what should I do? And now, my congrats, we've officially entered into the loop of analysis paralysis. And our working day is almost over and we are still stuck. So let's analyze what happened. Seems pros and cons list is not so suitable for this type of task. It's okay only for one option, but when we have 2 or more options, we see all the drawbacks and would like to somehow combine it together to get only benefits and avoid any problems. And our brain tries to generate the ideal variant that doesn't exist. And now let's determine what decision quality and outcome are. This is possible relation between decisions and outcomes. We can conclude that good decisions don't always lead to good outcome. For example, bad luck. For example, you've chosen a popular UI library, but later it gets an unexpected issue So the project is delayed because of the library's bugs and lack of support, or vice versa. You picked a random framework you aren't familiar with, and then surprisingly, you've got a smooth development and great performance. So luck does take place in our life, but we can do anything with it. So we should focus on things that we are able to control and increase our probability of success. And now let's talk about the time we spend on decision making. We often assume that the more time we spend, the better decision will be. This assumption comes from the idea that efforts always pay off. But reality looks a little bit different. And if we have too little time, our decisions is usually poor because we rushed. Otherwise, if we spend too much time, we get stuck into overthinking and fall into analysis paralysis. And eventually, we are so exhausted that we just pick something randomly. And then comes the optimal decision time, where we make a solid choice within a sensible time frame. So more time doesn't always mean better outcome. And we are besieged by so many problems. But don't worry, I'm bringing you strategies for making better decisions. And first of all, we need to spot and avoid cognitive biases. Here is the common situation. For example, you are choosing between Redux and the Stunk, but you already prefer Redux deep down. So you only read articles and opinions that praise Redux and ignore anything good about the Stunk. This is bias and how we should handle with it. Actively look for arguments against your preferences and play devil's advocate. Challenge your own opinion. Here is an example of sunk cost fallacy. For example, you're building a custom component system. It's messy, time-consuming, and full of problems. But instead of switching to a well-supported library, the team keeps pushing forward just because so much time and efforts have already been spent. How to deal with it? Set a stop loss in time, for example, 1 hour, 1 day, and define clear success and failure criteria. Example of bandwagon effect. For example, you see lots of developers on social media adopting microservices, and you push for migration just to stay trendy. Here we should focus on our real project requirements, not trends, and look for case studies similar to your project. And the next important question, where we can speed up. First of all, if the decision is easily reversible, for example, choosing between 2 button styles or icon sets, and we can change it later easily, so with low cost, we can decide quickly and move on. And another case of low risk, even though it's not reversible, for example, picking Chakra UI or Material UI, for example, you ensure that both are good enough for your needs. So make a coin flip and move on. Also, great solution, making irreversible decisions reversible. And we can implement it via feature flags, just on and off desired functionality without deploying new code. Our friends design patterns which decouple the logic and provide flexibility. For example, MVC, clean architecture, dependency injection, A/B testing for those who would like to test several realizations for one feature and choose according to measurable data. micro frontend architecture in which you break frontend into small parts that are easily interchangeable in theory, and version control, of course. And an ultimate framework for retrospective and current decisions, the decision tree. The algorithm is following. First of all, we define the problem and identify all possible outcomes for this problem. Then estimate probabilities for each outcome and choose the path with the desired outcome and reasonable probability. And let's get back to our interactive scenario. Just to remind you, we discovered bug in production. No one has reported it yet. It's critical. It's in large old legacy code, and no one in your team really understands this part of code. So first we should set the main goal. And in our case, our priority is that users shouldn't face the crash. It should be a fast solution, and at the same time, we admit that solution can be temporal. Let's build a decision tree, and we start with the problem at the root, the bug in production. From there, we have two possible outcomes. First, no one noticed the issue. And honestly, the chance of this is almost zero because it's a pretty important feature. And the second one, a client eventually reports the issue. And let's be real, this outcome seems much more likely, and we will stick to this branch. Okay, moving on. Once the client reports the issue, we face two options. We can fix it quickly, or we can't fix it quickly. And probability of these two outcomes is about the same, 50-50. If we can fix it quickly, then the fix could be stable or brings even more damage. And here we have a probability 50-50, but it depends on the previous steps, so it's 25% for both. And if we can't fix it quickly, we can just disable the feature. Of course, it's not so convenient for users, but at least we have no crash. And also we can spend days on debugging. And after debugging, we will have outcomes like we found a workaround, or we can fix it, or fix requires huge effort. And if so, we should refactor the code. And after refactoring, we've got two options, like the issues gone as itself, the issue still occurs, or more issues found after refactoring. And our decision tree is ready. And now let's see which path looks best according to our goal that is in right top corner. And after estimating likelihoods for each outcome, we get something like 25% of stable quick fix, 37% of success of disabling the feature, and only 2% that we can successfully refactor it. And as you can see, the highest probability of success comes from these two paths, but we should watch out because here we have a risk of sunk cost fallacy, so we should mitigate this risk somehow. And our final solution, set a hard time limit on the quick fix attempt, say 2 hours. And then if it's not stable by then, we should disable the feature, communicate with clients, and move on to our long-term plan. Well, don't be tired. We are getting to end, and let's wrap everything up. So no decisions is 100% guaranteed, and we should estimate best case, worst case scenarios. Also, we should accept risk and uncertainty in our life and make irreversible decisions reversible, and of course, spot and avoid cognitive biases. And that's it. Thank you for watching, listening.
Thank you, Ekaterina. That was great. Also, I've also seen this before, but it's still really good. And, some of these things can even be adapted to like non-developer roles. So, yeah, we do have some questions already. We had questions as you were presenting. But it seems like people enjoyed it, so that's great. So let's now move to, oh, by the way, Vladimir, I don't know if you guys saw it on the chat, but Vladimir sent the author of the course is Jason Mays. I hope that I'm pronouncing it correctly, but yeah. So we have some questions. What are the frameworks you use in front end, like React and other frameworks, like for CSS and for data fetching from API and for global state management? Well, that was a long question. Did you get it? Do you want me to read it again for you?
Which frameworks I'm using usually? Yes.
Sorry. Do you want me to read the question again, or that was just the
I mean, which frameworks I'm
yes.
using?
What
Yes.
are the frameworks you use in front end, like
Mhm.
React and other frameworks for CSS and for data fetching from API and global state management?
So honestly, I don't think that it makes sense because we should always adapt to project needs. But I have had some experience, of course, with the React, with the Angular, with some other stuff and Vue, and for managing states, of course, I've tried Redux and Reatom, I believe. Also, on our current project, we don't have like library state management. We have our own approach. So I believe that as developers, we just should know basics and adapt to project needs and to current team.
That's cool. So now we have not a question, but opinion from Ramazan. He said, once I saw your post in LinkedIn about choosing between two similar options, your advice was to choose any, as the result will come with its advantages and disadvantages anyway. It helped me a lot afterwards, so thank you. That's nice. Thank you, Ramazan.
Thank you.
And another question, can you give an example of a decision you regret making in your career and what you learned from it?
Well, I feel that I don't have huge mistakes, I hope, in coding, let's say, and in programming. But all my problems connected with the time management and overtime as a consequently, for example, I can spread my efforts and time to try different approaches for one task, and it usually takes so much time and efforts, and it leads to overtime and burnout eventually. So this is a huge problem that I am trying to fix, and even now. So what I understood that we are responsible for our mental, emotional, and physical health, and we should, in the right time, stop ourselves and recharge. because on our work, our team, so we needs to be with a smile and not be just in a bad mood and condition. So we should always somehow stop our and decrease our speed, our pace. Maybe it's only millennials. I don't know how to pronounce the problems. But anyway, yeah, that's only my personal
That's great.
drawbacks.
That's great. Thank you for those insights. We have some people thanking you for your presentation, for the group presentation, and the interesting giraffe. One last question that we have here is it okay to use different state managery, I'm not sure if I'm pronouncing it well, in one project, like Redux and another one?
Well, if this project has micro front-end architecture, I believe we can combine some different state managers, but I don't feel that we should overcomplicate our project. If you have two different teams, for example, that's okay. But if only one team manages these two micro fronted projects, I don't feel that we need different expertise in this. So we should keep things simple. This is the right way.
Exactly. Okay. Thank you. I don't think there are any more questions. If you have some questions, you can also message Ekaterina on LinkedIn. I'm sure that she'd be happy to answer them. Thank you so much, Ekaterina, for the presentation. It was amazing, as always. So yeah, that's about it. Thank you all for coming and joining. We're looking for speakers for our next dxTech Talks online in person. So if you want to be a speaker at one of our events, feel free to apply through our website, which is dxTechTalk. .devexperts.com. You can apply through there. And if you want to just, come to our future events, you can just follow us on social media where we post everything. So thank you guys. And I hope to see you again soon. Bye bye.
Thank you. Bye.